Hi friends, in this video let us learn about common gate amplifier. Right, so before watching this video, kindly go through the T model of MOSFET, then you can understand this class very easily, right? So because we are going to use T model of MOSFET in this class. Okay, so a common gate amplifier is drawn here, right? So this is common gate amplifier. This is one in MOS. Okay, so the gate is grounded because it is common gate. This is RS. This is VS. Here I have output. This is RD, drain distance. Here I take output. Here I take output resistance RO, and here you see, here I take input VI, right? So the resistance across the input terminal is input resistance. Okay, so in order to analyze this circuit, by analysis means I find input resistance, output resistance, and the gain, right? So to analyze this circuit, I have to draw T model of the transistor. So this is source, this is gate, this is drain, right? So up to this point, there is no change. It is external area. So for MOSFET only, we draw T model. So this is simple, same as this one. So here it is RS, here it is VS, right? So this is source terminal, plus minus. Here I take VI, I calculate VI. The resistance across this terminal is input resistance RN, I can say RI. Okay, so after this we have drawn. Then the transistor should be replaced by T model. That is an equivalent model of the transistor, right? So how I'm going to draw this one, I can draw like this. So for transistor, we know in T model of the MOSFET is this is I 1 by GM, here gate G. So after this it is over. Then as usual, drain resistance is available at the output RD. Here P across this RO, here BO. Okay, so we have drawn. So transistor replaced by equivalent circuit. So from this diagram, what I say is I find RI. What is RI? RI is the resistance between the source and the ground. So from RI, it is a resistance between source and ground. The gate is also grounded. So instead of calculating RI here, I can find RI across this also. So across this source and ground, what is the R? R is 1 by GM. So RI is 1 by GM. Right? So because gate is also grounded, so this is also grounded. Instead of finding between this source and ground, same resistance, RI is 1 by GM. So from here we can identify what is RO. Directly we can say RO is RD only. Okay. Next, what we have to find input resistance we found. Next we have to find the AV. AV is equal to VO by VI. So from the diagram, what is AV? So the current flowing through this terminal is I. So this is I is coming here, and it is going like this. So VO is, it is entering through minus. So VO is equal to opposite sign. VO is equal to minus I to RD. What about I? See what is I? See, this is I. This is current I. The same current flows here because here drain current is, gate current is 0. So I, this is I. So what is the I? I is a current flowing this source and this from here to here. Let us assume, right? So I can say instead of that, I is equal to, I can say instead of, see, it is a source terminal, it is grounded. So what is the voltage across source and ground? So the voltage across source and ground is VI. But here it is opposite. So instead of taking this voltage, I take this voltage because it is source, it is ground. So here I can take, instead of this ground, I take this ground. So I is coming in this. So what I do, I is equal to Vi by resistance. But here what we know, this source is here, here it is minus terminal, right? So I put opposite sign. So what is the thing? Vi is equal to minus Vi divided by 1 by Gm. So what is the reason for this minus? You see, actually current will go from plus to minus. If I put like this, actually current will flow from like this. But if I put here, it will be, it is plus, it is minus, so it is going in the opposite direction. So it is like this, right? So minus to plus, it is entering here, right? So it is minus. So for that only I put minus. So minus Vi divided by 1 by Gm. So I is equal to minus Vi. So what is VO? Sorry, AV is, it is VO by Vi, right? VO is equal to minus I into RD, minus I into RD, right? So I is equal to minus Vi, sorry, here I put like this. VO is equal to minus I into RD. Instead of I put Vi, so it is Vi by 1 by Gm RD. So VO by Vi, which is nothing but AV, that is equal to Gm into RD. So this is the voltage gain of common gate amplifier. You see what is the difference between this one and the common source? This voltage gain is nothing but minus of voltage gain of common source. Why? This is minus. What is voltage gain of common source? Sorry, voltage gain of common source. For common source amplifier, it is minus GMRD. So which is equal to GMRD. So from this, what I understand here, we have plus. That means no phase shift between input and output. In common source, this is 180-degree phase shift between input and output. That is the only difference, right? So in magnitude wise, there is no change in gain of common source and the common gate amplifier. Only phase will change. Common source will introduce 180-degree phase shift. Common gate will not introduce any phase shift. Next, we derive overall voltage gain. So overall voltage gain. The overall voltage gain is defined as AVO, that is VO by VS. Whatever we studied above is VO by VA is small signal voltage gain. Now we see overall voltage gain. So VO by VS. VO by VS I can write as VO by VI into VI by VS. So VO by VI already I found, that is AV. So AVO is equal to AV into Vi by Vs. So from the diagram of common gate amplifier, here you see, this is Vi, this is Vs. So the resistance here is Ri. So what is Vi? Vi is a voltage across resistance Ri. So I apply voltage divided by total voltage Vs into Ri divided by total resistance Ri plus Rs. So what I do here is, instead of Vi by Vs, I substitute AV. AV is GMRD. So if I include a load resistance, it is becoming GMRL parallel, right? So AV is GMRD only, but I include a with the load resistance. Now I include load resistance RL, right? Next to Vi by Vs. Vi by Vs, we just now only we have seen Vs is equal to, sorry, EI is equal to VI by VS. Okay, I put here. Here itself I reduce VI by VS. You see, VI by VS is equal to Ri divided by Ri plus Rs. Ri is nothing but 1 by Gm. So 1 by Gm divided by 1 by Gm plus Rs. So instead of VI by Vs, I substitute 1 by Gm, 1 by Gm plus Rs. This one will be cancelled. So AVO is equal to RD parallel RL divided by Rs plus 1 by Gm. This is overall voltage gain. So here you see the overall voltage gain, it is equal to the RD and RL both are in the resistance in drain circuit. So this is R in drain circuit, total resistance in R total in drain circuit. See, Rs is input side, Gm is also output side, so it is a resistance in total resistance in gate circuit. Or sorry, it is source circuit. So simply voltage gain is the ratio of resistance, total resistance in drain circuit and total resistance in gate circuit. So these are all the things we have to remember whenever we work with the common gate. So what is the conclusion? So Ri, the input resistance for common gate is 1 by Gm. Ro is Rd. If you include load resistance, Rd parallel RL. AV, small signal voltage gain is GMRD. No phase shift between input and the output. Right? So these points we studied. And the fourth one is overall voltage gain, AVO, that is VO by VS. It is resistance in drain circuit, RD parallel RL. It is RD parallel RL. Resistance in source circuit Rs plus 1 by. So these are all the things you must know whenever you work with the common gate amplifier. Thank you.